Okay, so today we're getting into Unit 8, Lesson 8, and we're talking about area and perimeter. So we're using our measurement skills. So our focus today is going to be to use a formula to find the perimeter and area of a rectangle, which you've done before, but this time it's going to have fractional side lengths. So we're going to start with what we know and look at whole numbers, and then we're going to go into the fractional side lengths. Oops. Okay, so we're kind of rolling everything that we've learned throughout the year into one. So first we're going to use a formula which has variables that we'll need to fill in. The perimeter is the distance around an object. So it's a linear measurement. It's the distance around something. And the area is the distance inside of something. So I'll kind of make this. Okay. So if you're thinking about our classroom, the perimeter would be measuring all four walls around and adding those up. And that would be like if we needed to wallpaper the room, we might need to know the perimeter. Okay. But if we wanted to carpet the room, we would need to know the area of the room because we need to know how much is in the middle of the room in order to cover it with carpet. Okay, so that's the two different. So if you look at your student activity book, we're on page 281. It has the definitions for you over here, where perimeter is the distance around a figure. So we're looking all around the outside, where area is the total number of square units that cover the figure. So it's all of these square units in here. Okay. And just a reminder, a square unit is something that has 1 unit by 1 unit size. And that unit might be a foot, it might be a mile, it might be an inch, it might be a centimeter. Whatever unit is being used, it's the same. It's one of each. Okay. So looking at formulas, here we have a rectangle that has one side that's 3 centimeters. Now this other side doesn't have a label on it, but knowing what we know about rectangles, opposite sides are equal. So if this side is 3 centimeters, then this side must be 3 centimeters. Same thing with this. This top side is 5 centimeters, which means this bottom side must be 5 centimeters. So in order to find the perimeter of that, we're going to take each side 3 centimeters plus 5 centimeters plus 3 centimeters plus 5 centimeters for a total of 16 centimeters. So from that, we can get a formula of length plus width plus width, or we can even be a little bit more precise with it and say 2 times the length plus 2 times the width, because the width and the length are just being added twice, so we can also multiply them by 2. Okay. So coming over here for area changes up a little bit because we're no longer worried about the distance around the figure, we're worried about the space inside this figure. Okay, get rid of that so we can have for our notes. Okay, so here we have a side that is 3 centimeters, and then we have a side that is 5 centimeters. So we know area equals length times width. And so we just take the information that we have and fill in for those variables. So the length is 3, the width is 5, and that leaves us with 15. Now if you look closely, the units change. This, for perimeter, it says centimeters. For area, it says square centimeters. The difference is this is a linear measurement. We are in one straight line here and going around the distance of that shape. Here, we are in square units. Notice we have this whole square covers this spot. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15, but these are square units. So that's why it is square centimeters as your label. Okay, so remember with perimeter, you just have whatever the unit is. With area, it's going to be a squared unit. Okay, so now that we've reviewed, this is all information that you've worked with before this year and in previous grades. But now let's come down to fractional side lengths. So when you look at rectangle C is actually just this green rectangle right here. This other part is helping us figure out and just visually understand what that square is. Okay, so looking at rectangle C, if we wanted to find the perimeter of it, we need to add all sides around it. So we have 1/3 plus 1/3 plus 1/5 plus 1/5. So knowing what we know about fractions, when we're adding, we need to have like denominators. Okay, I know that 3 and 5 both go into 15, so I can change all of these to 15. But now I have to think, okay, how do I get from 3 to 15? I multiply by 5, so this is going to be 5/15. This is the same. Going from 5 to 15, I have to multiply by 3, so this is going to be 3/15, and this will be the same. So now I can add those up. 5 plus 5 is 10, 3 plus 3 is 6, which gives me 16/15. Now using my fraction brain again, I realize that's an improper fraction. So I can simplify that to 1 and 1/15. And my label would be centimeters because this is a linear measurement. So that would be finding the perimeter of that. Okay, now how this other box is helping you is it's saying this is 1 centimeter and this is 1 centimeter. So this rectangle, this side is 1/3. So notice there's 2 other ones to make 3 because 3/3 would make 1 centimeter. So this part of it right here is there to help you visualize the size of that. And it's also going to help you with areas. Coming over to rectangle D, we're looking at the green square. This green square is 2/3 centimeters by 4/5 centimeters. So following our formula of length times width, we have 2/3 times 4/5. Now, using our fraction brain, we know multiplication, we do not have to have like denominators. We just multiply across. We can check for cross simplification to see if that helps us. But we have 8/15. 3 times 5 is 15. And remember, these would be square units. So this would be square centimeters. Okay. Now, another way that you could figure that out using this model here is once you make the whole centimeter, notice again, this represents 1 centimeter, 1 centimeter. And we have 2 of those and 4 of those. So total, we could even count this. 1, 2, 3, 4, 5, 6, 7, 8. And we know that that is going to be our numerator. And then how many total make up 1? 8, 9, 10, 11, 12, 13, 14, 15. That becomes our denominator. Okay? So drawing an area model helps you understand visually what it is you're doing with the formula. Okay? So let's look at how we can use that information to help us with our work tonight. So on Think Central tonight, you're going to be having some fractional units where you need to find the area and the perimeter. It's going to ask you the difference between why is perimeter in centimeters and areas in squared centimeters. Okay, so remember there's squared units there. Okay, so it's going to be very similar to this where it gives you a rectangle and then it's going to have a shaded part and you're going to need to find the perimeter and the area. There are also some word problems on here. Okay, so something like this. I'm sorry, these aren't word problems, but they're going to be missing side lengths. So for example, let's look at number 8. We have 2 and 10 and 4/5 meters on this side and then 2 meters for the height here. So we need to find the perimeter and area. we know both of those, so we can figure out the extra missing sides because we know opposite sides are equal. Okay. When we come down to number 12, let's say, notice it's giving us the area, but it's leaving one side unknown. So we need to know how to figure that out. Okay. So going back to our formula, area equals length times width. Again, if we plug in the information that we have, then we can figure out the other one. So we know area equals 2 square feet. The length is unknown, and the width is 1/3 feet. So from that information, we can figure out the length by dividing 2 by 1/3. And that would give us what was left over. Okay. So when you have a missing side here, remember to use your formula, plug in what you know, and then use division to help you solve that. That's nothing new. We've worked with that before, so it shouldn't be too out of the ordinary. For the word problems, there's going to be one that is just normal finding the area and perimeter. It's very similar to number 15 where it says Brian was tiling a patio and ran out of tiles. The width of the remaining area is 2/3 yard and the length of the remaining area is 4 yards. What is the area Brian has left to tile? So it's asking for the extra area that's not finished. So you'd have to multiply those two numbers together. Okay. There are also there's one like number 19 I wanted to point out to you. If you read number 19 carefully, it says Margot wants new carpet and new wallpaper border for her bedroom. The room is 5 4/10 meters long and 4 7/8 meters wide. Then there's a key word here that says about. How many square yards of carpet will she need? And about how many yards of wallpaper border will she need? That magic keyword about means that you are going to be rounding. Okay. On Think Central Design, it actually tells you to round to the nearest half unit. Okay. So you'll be rounding to the nearest half unit to solve that problem. I believe that's number 10 on Think Central tonight. Okay. So again, we're working with area and perimeter and finding fractional side lengths and using rectangles with fractional side lengths. And then we'll carry that information on. This is not necessarily new information. We're just used to using whole numbers instead of fractional sides. So that would be a little bit different for you to practice. But other than that, it's all review of information that you've used at the beginning of this year, throughout the rest of this year, and then even in previous grades.